Okay, so what I have here is y equals 3 times x minus 1 squared. And what I'm going to do is show you how to graph that by using vertex form. So a lot of times when we're using vertex form, we want to be able to understand what our a, h, and k are, because we know that a is going to tell us our dilation and also our reflection. H is going to tell us shifting left or right. And k is going to tell us if we're going to be shifting up or down. So when looking at this equation, I have a equals 3 and h equals 1. Now, we've talked about this again, but remember it's x opposite of h. Well, so it's x opposite of positive 1. So since I know h is equal to 1, and I can also say k equals 0, because I'm not adding or subtracting a number outside my function, what I'm going to do is all I'm going to do is shift this graph over 1 unit to the right, but then also I'm going to have a dilation of 3. So when I'm graphing this, all right, it's important for us to look at this, and we're going to take our parent graph and just shift it over 1 unit to the right. So originally my vertex was at 0. Now I'm just going to shift it over 1 unit to the right. However, I have this dilation of 3, and I need to understand how is that going to affect my graph. And the best way I can tell you to do that, with kind of making this a little bit simpler, let's just look at, if here's y equals x squared, let's look at y equals 3x squared. All right? So if I was going to do a table of values, x, y, what I can do is, let's see here, I'll do -2, -1, 0, 1, and 2. And if I was going to do y equals 3x squared, all right, and I'm going to kind of do this in my head and kind of talk my way through it with you. If I was going to take 0, 0 squared times 3 is still going to be 3, 0. So therefore, my vertex would remain the same. However, when I go to -1, -1 squared is 1, but now it's going to be multiplied by 3, which is positive 3. And then 1 squared times 3 is going to be positive 3. So instead of going over 1, up 1, now I'm going to go over 1 and up 3. Left 1 and then up 3. And that's going to be the same thing now when I do 2. When I do 2 squared is 4. 4 times 3 is 12. And then 2 squared is 4. 4 times 3 is 12 as well. So now instead of going over to up 4, I'm going to go over to up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And what you can see is now my graph has been what we say either vertically stretched or horizontally compressed. It's much skinnier. And so that's going to be the same thing I'm going to apply now when I'm looking at this. Rather than going up 1 over 1, I know I'm going to go up 1 over 3 and up 1 over 3. So my graph is going to be much skinnier. So now let's go and take a look at what are our important points. Well, our axis of symmetry has now been moved. Right? We've now translated our graph over 1 unit to the right. So now we can say our axis symmetry is the vertical line when x equals 1. And that's going to be the graph that that's going to be the line that now my graph is symmetrical about. Our vertex has also been shifted 1 unit to the right. Rather than being at 0, 0, now it's at 1, 0. My axis of symmetry, my y-intercept, well, we can see my y-intercept is now at 0, 3. And my x-intercept is where the graph crosses the x-axis. And we can see it doesn't cross it, but it actually touches it at the vertex, which is 1, 0. So there you go, ladies and gentlemen. That is how you graph in vertex form and find the important points. Thanks.